everyone, am I audible? Please write in a chat box. So, hi everyone, how are you doing? A very good evening to everyone. I hope you're doing well. And if you're feeling great, please write in the chat box. Drop an eye emoji. So this side Shrishti Maheshwari from Team Pregrad. So as always, I wanted to introduce what is Pregrad. Pregrad is an edtech platform with a mission of we bridge the gap between student and the industrial mentors. And we started your career before graduation. Pregrad was founded by Ankur Saxena and Madhav Chaturvedi in 2021. And Pregrad offer many upskilling programs, which is powered by IBM, Wipro, and many other companies also. So let's begin the session. Are you excited? Please, on a scale of 0 to 10, how much you are excited? Write in a chat box. 0 to 10. Okay, so much of excitement. So let's welcome to Ritesh Sinha. A very warm welcome to Ritesh Sinha, who is a guest speaker of today's webinar, who is a software engineer 3 at Walmart with over 5 years of experience in the IT sector. So Ritesh will be a guest speaker of the webinar. Everyone, please give a warm welcome to him.
Thanks, Srishti, for having me, and thank you everyone for being here today. So, as Srishti already gave me my introduction, I'll just give my short introduction before starting. So, I graduated in 2018, and post that I've been into corporate section and companies, and mostly in the analytics domain. So, analytics and a bit of data science is what my domain is. And today we'll be starting with SQL.
So hi Ritesh, how are you doing?
Yeah, doing great, Srishti. How are you today?
I'm good too. So audience, please, just a quick reminder to all the audience, your mics and cameras are turned off for this session. If you encounter any issues, just raise your hands. I'll turn on your mics. Okay, so let's make this session fun and engaging. Thank you everyone, and thank you Ritesh. Session is all yours now.
Okay. Just give me 1 second. I'll just share my screen. Let me know, guys, if you can see my screen.
Yes, it's visible.
So we'll start with RDBMS. Relational Database Management System is a type of database. There are typically two types. One is RDBMS and the other one is NoSQL. So this one is mostly used in industry across, I would say, the entire product domain as well as consulting domain. This is something which is very much used because relational database system is when different tables have relationships between those. So this helps a transactional systems as well as different kind of systems to actually use this database for analytical use. So when you use a database for analytical use, you use your, let's say, you show your data, you analyze your data, you show your data as the report in the reporting structure as well as the ETL structure, which is the ETL, I would say, is extract, transform, and load. So first we cleanse our data and we load it into systems, and from there we show it as a report. So what I mean by this is, let me just
Ritesh, could you make it full screen?
I didn't because I also have to share my whiteboards.
Oh,
But okay, Right. So we'll start with how the relations between those different tables are. So let's say a table is like a structure where you have the data, the rows and the columns. So I'm sure you would be aware what row and column is. So column would be anything which is horizontally storing the data, and rows will be vertically storing the data. So it's a collection of rows and columns. And when you have relationships between two tables, that defines a RDMS, or a relational database management system. So schemas is nothing but how these relationships are together, and the entire tables and relationships together are called schemas. So let me just see if I can get a whiteboard here. How these relationships are together. Can you see the whiteboard?
Yes, it's visible.
So let's assume that you have a table, and the first table is, let's say, a order table. Order table, I'm speaking about the industry that I am working on. So I work with Walmart, and we have a lot of transactional tables and order tables, customer tables, and these kind of tables. So I will be explaining, the entire session that I'll be taking today is mostly across how these are managed in the industries, and how these will be handled there. So order table will mostly have your order IDs. So I will talk about what IDs are and what primary keys are later. So it will typically have one column, let's say order IDs, and then you will have your different customer IDs, like who placed these orders, customer IDs, and let's say you will have the sales numbers. So let's say one person ordered something, an iPhone of $1,000, something is that. And then a different table is with customer names. So these customer IDs are just here, and you would have customer IDs in this table, and you would have your customer names and other details of customers. So once you have that, so now let's say these are two different tables, but let's say I want to show somewhere that for this order ID, what is the customer name? So that data is not present here. So I would have to somehow relate these tables together. So that's how I relate these tables from here to here, since customer ID is present here and customer ID is present here. So I would relate these tables together. And now when on the front end systems, I want to show something, let's say an order ID, or let's say for each customer, how much orders they have placed. So let's say I have ordered like $5,000 of worth of products from Walmart or from Flipkart, and then I could show that under my name. If I want to see something as that, I would use these relationships and show that. Now these order IDs or customer IDs that we have, order IDs here and customer IDs here. So this row, this customer ID is a column. So each row in this column would represent a unique customer, right? So for me, I would have a, let's say ID, which is mostly taken as integer. Integer is nothing but a number. So integer IDs for me, there is, let's say for you have an integer trustee has one integer ID. So for each customer, there is one ID generated. So when there's a unique column in a table, we call it as a primary key. So this, let's say, is a PK. We call it in the database, we call it as PK. So now this PK, when connects to your customer ID, here it is called foreign key. Since this key is present at a different table, so, and it is present here, it's called a foreign key, and it is being connected to this table using a foreign key. So primary key here connects to the foreign key in the different table. So that's how this is made. So now let's say you have multiple, let's say you also have regions. Let's say this person, this order was made in, let's say, a certain part of US. So region IDs are there, and region ID is there, and then you have a region table.
Ritesh, sorry for interruption. Like there are students who are demanding to. Could you please explain in Hindi and English both?
Okay. All right. So, um, all right. So region IDs क्या होता है कि you have, let's say US में किसी ने order किया है from Tennessee, or somebody ordered from, let's say Texas. तो वहां से जब order किया तो each region का एक ID बनता है. तो ID again is uniquely उसको explain कर रहा है. Like let's say when we talk about India, so Flipkart is also a Walmart brand. So yeah, आपने Flipkart से order किया and you are from Delhi. So Delhi is a state, right? So it's a union territory. So you would have one ID for Delhi. So एक ID दिल्ली का generate हो गया. Let's say it is ID 1 or something, or let's say 1 1 2 3 is the ID for Delhi, and 1 3 4 is the ID for Uttarakhand. So somebody ordered from there. So again, we will have only a certain unique, like let's say when you talk about states, you will have a certain number of unique states in each country, right? So उतना ही generate होगा. So the region ID, when we talk about the region ID, so region ID will be unique for that table. उस table के लिए बिल्कुल unique होगा. But for this table, you will have multiple region IDs. So आपने order किया है उत्तराखंड से, there can be another person, किसी और ने उत्तराखंड से order किया होगा, किसी दूसरे ने भी order किया होगा. So यहाँ पे उसके repeated होंगे, like काफी टाइम से region ID होंगे, मतलब 10 15 50 कुछ भी हो सकता है, बट यहाँ पे वो region ID एक ही बार होगा. So हमने यहाँ से relate किया, ऐसे हमने 3 4 अलग अलग tables बनाए हुए हैं जो कि इसको explain करते हैं, and then table से connect कर दी. So this is what a schema is. So now this schema resembles something as what? The schema resembles a star structure, right? A star structure. So this is called a star schema. This is called a star schema. This is mostly preferred in, I would say, all corporate sectors because ये बहुत speed काम करता है. So when I talk about speed is, अभी आप कोई भी query लिखते हो, SQL is what? SQL is structured query language. So आप query लिखते हो to get data out of your databases. तो जब वो लिखते हो, वो कितने स्पीड से चल रहा है, what is the speed of that query gives you a very upper hand in like corporate, right? So you would want, let's say, you make reports, you make systems out of, you make applications out of these databases. So how that is performing, so as a user and as a business, agar if I am a business, I am having a application or a let's say a report, so I would want कि ये speed हो काफी. So optimization of performance is a very good big deal in corporates. So your schema should be optimized, and star schema is one of the most optimized way to do things. So this is the first schema. I think that there are two important schemas which everybody should know about. So now this again, when we talk about these two kinds of tables, so if you will see, एक table बीच में है जो कि जिसमें सारे details हैं, and then there are multiple tables which are attached to it, so which are connected to this. So now these main table is called fact table, and the tables that you see on all the corners, ये कोने वाले table को dimension tables कहते हैं. So now what a fact and dimension is, fact table में सारा data रहेगा of transactions. Just if somebody pings or asks about, could you please tell them because I can't see the screens there.
Yes, everyone, I turn on your microphone. Just raise your hands and speak one by one. Yes, Vijay Shri. Vijay, do you have any question?
No, ma'am, it was by mistake. I'm sorry.
Okay, no issues. No issues. Ritesh, could you please explain a little bit about concurrency control?
We will reach there. We will reach there. We will reach once we go ahead. We will reach there as well. So let's once talk about dimensions first, and then we will go ahead and we'll create databases and we will reach there. Concurrency control is something which we talk about in later languages. So when we talk about dimensions, your let's say fact tables will explain you what exactly in your is in your main areas. Let's say when you talk about orders, so it will explain you the sales and the number of sales that has been done, the total amount of sales. So it will have your explanation and entire transactions. And dimensions में क्या होगा? It will explain your fact tables. So यहाँ पे क्या हो रहा है? Customer ID जैसे fact table में है, and then there is your fact tables को explain करते हुए there is a dimension table which will have entities and explaining your fact tables such as customer table. This was customer table. Then you have region table. So this will explain your fact tables. Now let's say अगर region का कुछ और explanation हो, let's say region के या customers के कुछ और explanation हो, customer का address का एक और table बना हुआ है, तो यहाँ पे एक और customer का address का table बन गया. फिर customer का let's say address के अलावा कुछ और उसका let's say likes and dislikes का एक table बना हुआ है हर customer का. So now this schema that you see, now this is called a snowflake schema that resembles a snowflake such as this. Right? A snowflake का जो design होता है वो आ रहा है. So now this is a snowflake schema. So now this is what a schema is in a database. Just 1 second, I'm getting a call. Just one second.
Wait for a minute, everyone.
Yeah, sorry for that. Please screen share it. Yeah. So when we talk about schema, those are that. And primary key we already talked about. Primary key will uniquely identify each row, and foreign key will reference a primary key in other table. So as we saw that on the dimension you will have a primary key. On your fact table you will have foreign keys. So now once Srishti was talking about concurrency control, this is something in a transactional tables. So you would have a lot of different types of tables. So in analytical world, you wouldn't use transactional tables. You used a different, like a denormalized table. So in transactional tables, what happens? So let's say for Walmart and Flipkart, you would have multiple tables which will have POS transactions. So when I talk about POS transactions, POS nothing is point of systems. So when you go ahead and when you go in a shop, let's say Chroma or Reliance store, you go ahead and you swipe your card. That system is called POS, where you swipe your card. So those systems results back into our industries where we have those data. So those are transactional systems. So transactional databases are very heavy lifting. They will have petabytes and terabytes of data. So now generally when we talk about, when we study databases, when we study SQL, mostly in our learning period, we only see data, let's say, 500,000 about that's on the higher end. I think when I was, in my college times, when I was reading or when I was studying, I would never go beyond 100,000 rows. So that's something there. But when you go ahead and work in a transactional world, you would see petabytes data, tens of millions and billions of rows coming in. So there you need to write your query very effectively and optimize. So concurrency system is what that database, a transactional database, will have read and write, and multiple times you could hit that DB without inconsistency in the data. So data won't be inconsistent. You will write and read at the same time. And it also has something called SCD, or slowly changing dimensions, what we call in databases. So it's a very vast database that you have in transactional systems. And there are mostly, I would say, DBAs, database administrators, who only work in transactional systems. So I wouldn't say a software engineer directly works on a database management guy, because a software engineer will work in coding. He will use your softwares to hit your databases, to retrieve the databases. Even like me as an analytical engineer, we would hit the database, we would read the databases, we would insert into databases, but we wouldn't manage a transactional systems. So transactional systems is specifically for a DBA guys, which are called database administrators. So that's something about that. And going forward, I also have set up a local SQL, so for us to understand how exactly it works. So creating a database in a table. So creating a database is very simple. So you would, the syntax for that is just create database with database name. And then when you create a table inside that, you will have to write something like this. So let's go ahead. So this, you can see my SSMS, or you can only see my PowerPoint till now. Guys, somebody.
Yes, Chavi, you will get your get the PPT. Uh,
So can you see my SSMS? You
yes,
can just see PPT.
PPT is visible.
Okay, let me just share again. Actually, I'm usually uh, having meetings on Google Meets, not Google Meet, Zoom and Teams. This is a little bit new.
No worries.
I think now you can see my SQL systems.
No, it's still PPT. You can open the SQL and choose a tab when you are selecting to
No,
start
I'm
filling.
sharing my entire screen now. I think it should be visible.
Yeah, now it's visible.
Okay. So if you see, this is a SSMS I have set up. SSMS is nothing but SQL Server Management Studio. So you can, it's a free tool. You can download it from your Microsoft site. Post, I would probably pass the link on to Shrestha. You could later. This is something which actually a hands-on thing. So better than just going through and learning it from a site. I would say get your hands dirty, go download this and start firing queries, so that will be better. So you would have, when you download this something, you would already have a base system set up. So you would have some databases, dummy databases already in picture, where you could fire your queries, learn to actually work on these systems. So typically, let's say you want to create a DB, you would do nothing but just yeah, so a database is created. So we move on to this database using here. So now anything that you do, you would be doing on that database. So there's another way of doing this. You could directly go here and select that database, or you could use something as use XYZ. So that is also same. So you could just fire that query. So if you fire that query, you will be automatically moving into that database, or you can just select it from here. Same, it's the same thing, right? Both are the same thing. So let's say now if I want to create a table, the syntax, let me just first explain the syntax what it is. So what we are doing here is we are creating a table called students. So create table is the automated syntax that you have, and the students is the table name that you would have. So now if you see, student ID is again the primary key that we were talking about. Primary key in our table is very important, because that's how you would actually use it as a relational database, how you would connect these to another tables. So once that happens, then you have the first name, the last name, and the birth date of the person. And then you would hit the query, and this would create a table. Now, at this point, this wouldn't have any data inside that. You have just created a table. So let's see. Now, either you're seeing this int, varchar, and date. These are data types in SQL. So data types is nothing. How would you define your types of data? So int is an integer. It starts from a certain number to certain number. Like it's an integer number. It's in your systems, it will start from certain number, a negative to a positive number. And first name you're taking as varchar. Varchar is nothing but, I think in your college you might have, I think if you're studying Java, C++, you might have heard varchar, but let's say string is something, or char is something, a data type that you might have already heard. So string and char is similar to varchar, but varchar here is generally used in SQL, because it's varchar will adjust your storages based on what you enter. So if I'm entering a very big name, it is going to adjust till 50. If I'm storing a small name, it is going to adjust till that as well. So last name is that, and date is self-explainable. So and the primary key is for same thing. So when you do this, this is going to create a table. Now this won't have anything So what I'm doing is I'm writing a lot of queries. So I'm just selecting the query when I'm firing it. So this query is executed and you have a table right now. So now when I select a table, you won't have any data into it. So this, the thing that I'm doing right now is I'm selecting the table. So I'm fetching data out of that table right now. So we use this statement in the next, I think the coming slides, we will enter more and we will see how exactly it is done. So the ID and F name is created. You already have, the column names created, but you don't have data into it. So you can enter data into it as well. See, you would have data in this table right now when I'm doing this. Correct. So you have, and you could, once you start, actually practicing, you will find a lot of scripts online. Let's say you will have multiple lines. So every time you will run it, it is going to insert a value. So when I'm running again and again, I am doing, hope I am giving your spelling right, Shasti. Yeah, so you'll see the new data is being added every time. So this online, you will find scripts with like rows and rows of data. You can enter it once, create your own database, create your own table, and then you can start practicing and firing queries and learning how to. After the session is ending, you will be able to do a lot on SQL, firing queries in different. You can fire subqueries, aggregations, and all of this you can learn. So going ahead, you have the aggregation functions. So this we are starting first because when we start and seeing the execution order and how to exactly write a query, you will need this. So I think anybody who is in programming background, you would have already visited the functions that we are currently seeing on the screen. So count will count the rows in your entire table. Some will give you a certain value. So some inside will accept your column name. Count can accept your column name, or you can just give a star. So when you give a star, it is going to count the entire table, the total number of rows in the table. Average will also accept a column name in the between the brackets that you see. Max is also giving you will accept a column name in between. Minimum will also accept a column name in between. So all of these are called aggregation functions, and you could use it directly. So if you see below in this example that we have, count star is nothing but it is going to give you the whole count of the total, and average is going to give you the average of the total. And from grades is like the grade table. Table name is grade. And next slide, we are going to study the different clauses that you can use. So these are the different clauses that in the earlier example we were seeing, we were using from and these where. So these are all SQL clauses that we have. So the from clause does nothing but it specifies the table that you need to query. So the table and then where is nothing but it specifies any filter that you would want to have. So let's say you're saying select star from a certain table where you would want that age, let's say in the students section we had, right? So they'll say I just want stress test data. So I would do something as so you see her ID is 2. So if I'm running this query, it's going to give me only her result. So this is filtering your data in a smaller snapshots. So you can filter it in any way possible. So you have different, I would say, filtering type of. Let's say you can use or and all of these to filter your data. But yeah, where clause is used to filter your data. So what is group by? Group by is nothing but it combines the data with an aggregation function. So let's say we were talking earlier about our order table, right? So you would have multiple orders. Let's say you get somehow you get the data of Flipkart. So let's say one day sales data you get of Flipkart, and let's say I have ordered 5 things from Flipkart or 6 things from Flipkart, and somebody else has ordered about 10, 15 on the same day. They have ordered multiple different things from that, and you want to get out that me, I have ordered how much worth of products. So let's say I have ordered 5 small purchases like up 500 600 rupees, and some way you want to see that Ritesh has ordered how much in total. So you would use what? You would use select my name, comma, and then sum of that sales column, and then you would group by based on my name. So based on the name column, you would group by. So it is going to show you how much you have I have ordered for that period. So group by is nothing but it together. It with the aggregation function, it always shows you uh, summed up data. So group by should all. So again, when I can stress this more that group by should always be used with an aggregation. So when you're talking about group by, it should be used with any of these. So other way it doesn't find a use. So group by is mostly used with an aggregation. And having filters your groups. So when I talk about having is nothing but, let's say, group, you're grouping by something, but you're also saying that you group by for a certain filter only. So group by, let's say I want to group by, just we're talking about me buying products. So I want to group by Ritesh data, but I want to group by that only if I have ordered above 100 rupees, you want to see that only. So you would just use having, group by with having. And then order by is nothing but it sorts the data. So order by has 2 clauses. It will be ascending or descending. So which is ASC and DESC. So ascending is like from small to big, and descending is from big to small. So aliases is nothing but how you would name your data, name your columns. So you could name your columns in any way. So let's say if I want to name my columns as X, Y, Z, I could do that as well. So that is something what aliases would be doing. So let's now see 2-3 tables that is already there. So there is a sales data table that I already have as a test. So first we will see what exactly is in this. And then we will understand what is the order that this execution handles. This is because we are currently in a different database. So the error that you're seeing, invalid object name DBO sales data, because this sales data is in a database called test, and we are currently in XYZ. So we will move into test, and then we will run the same query, and you will see that you have the data. So if you see, it is nothing but there are multiple people who have ordered some products or the sales amounts, and these are active or not is what we have. So this is just one column where some place you have active and some place you don't have active. So if you see, there are certain times when these people are doubled. So Pawan has ordered something of 2,500. Pawan has also ordered something of 3,000. You will see Avatar has also 2 orders. I think Nimit has 2 orders, and multiple people have, and certain people have single orders as well. So let's write a query where we will see everything about what we were talking about. It's actually not a sales data. It's mostly these are salesperson who have done these sales. It's not about how much they have ordered. Because now I just saw that there is an employee name here. So same thing that I was talking about, whenever you include a sum up. Now what's happening, that Pawan UVC was repeated 2 times, right? Now when you do a sum up, so let's say I'm doing a sum of sales of Pawan. So his 3,000 and his 2.5 thousand is summed up. But how will it show in correspondence with some name? Because if it shows in correspondence with some name, he will have two Pawans and the sum is just one, right? How is it going to show that? So when I'm not including the employee name, the sum is going to work perfectly. But now, since this has to be clubbed with the employee name, and there is Pawan two times, and the sales amount would be one for Pawan because you're summing up that. So that's why there was an error. So now when I want to call this, if you see the column name is nothing, I want to call it something. I would call it at sales. So this is what alias was referring to. So now this column name is sales. So this is what an alias is, that we were just having this alias is there. So now we have seen select, we have seen alias, and we have also seen from. So let's say we talk about, let's again see our data first so that we can understand better. So let's say we want to just see the active sales employees. So these are probably, these employees are no more a part of the company. So these are active. So you want to say the active only, the sum of the sales for the active salesperson. So you would say where see. So it is going to sum up for only those who were active. It is not going to sum up for everybody that we were earlier having. So when you will see that when I run just this query, it is giving me a bigger amount, right? And when I run the full, it is going to give me lower amount because it is leaving out these four people, right? These four people it is leaving out. So that's there. And now let's say just take the one query where we are having everything together. So now it is clubbing up for people who have who are active and grouped by their employee name. So you will see Pawan is now 5,500. Earlier we were seeing what? That Pawan has two data, which is 2,500 and 3,000. When it is clubbed, it is showing 5,500 for that. So we are summing up, grouping by the employee name. So say we have grouped by, Pawan is now here. I see, I think I'm hearing few questions, Rashid.
We have questions how you drag the data into your SQL query, how filtering is done at Walmart for large set.
Okay, so this data, this is again a management studio. So you would have multiple management studios. So based on what the data, currently the SQL server that I'm using is a local SQL server. So I'm having a SSMS data. So at Walmart, we would have, we are using Google BigQuery. So Google BigQuery is nothing but NoSQL database for Google, provided from Google. So we use Google BigQuery, and the querying also is fired on that. So this is just a base, or I would say the IDE or the top end where you fire your queries. So SQL will be same for both ends. Probably there are few differences, like in SQL you would have I would say minor function differences, rather than the base is 99% same that you would have there. So here I'm just dragging these tables so that I don't have to type it. So it's just the name that I'm dragging. So I'm dragging it here. It would just drag the name. So I can either type the entire thing or I can drag it. So it's one of the way that you would have. Same thing is, this is again specific for SSMS. You wouldn't have the same if you're using another tool. So let's say if you're using Google BigQuery, I don't have the option to drag it. So there you wouldn't have this display of tables. So this is a local systems. There you would have cloud systems. So in Walmart, we have cloud systems, and there there's no option to drag. You will have to write the entire thing. So in there, the entire, if you see, this is dbo.sales data. So the actual way that we write there, it is going to be your database dot your schema and then object. Then object is the whole way to write a table name. So there we would have, let's say, Walmart dot something something dot schema dot something something and Walmart dot schema dot something, and then the view name, table name or view name is how we would go for that. But yeah, this is again a front end system. SQL is a language. It's not let's say if you are a Java guy or a Java girl, or you're using C, C++, you would use different IDEs, right? So it is similar to that. You would use different IDEs, you would use different database, but the language is same. So language across is going to be same. I'm sure that would answer your question. Now, again, when we talk about, let's say we are using now aggregations that we saw, we are using aliases. So sale that I have done as is your alias. You're using from, that you're taking that database name. We are using where, which is filtering our data. We are using group by. Now we will be using having. So let's say I want to pick only those sales amounts whose sales are, let's say, greater than 2,000. I wouldn't want anything else. I would want to pick only those people because let's say 22,000 is the quarterly criteria that we have picked, and we would say that I want to pick only those employees who have done better than that, something as that. So any reason could be, and you're using something as that to get that. So still you will be getting the same thing, but you will be picking those only. So see, now only Pawan and Kishan are picked up because it would only take those whose sales are above 2,000. And the last one is order by. Now I want to order by sales. So let's say just now it was ordered by as a descending order. This 5,800 was on top. We changed to ascending. Then it was 5,800 was top. We changed it to ascending. It is ascending. So this is the keyword we use by order by. ASC is for ascending. DESC is for descending. So descending won't change anything because it's already descending. So now if we are doing descending, it's already descending. So it's not going to change anything here. So we have used all the clauses together in one. So on a typical scenario, while you're working in a corporate, you wouldn't use all the aliases or all the clauses together. But yeah, you will be having multiple cases where you have to use few of them together. So I would say alias is frequently used. From is the basic. From and select is basic. Where is basic. Group by is also basic. Having an order by we generally don't use, and I'll explain you as well why. So now the execution order. So how the background thing works. So now you have fired queries. So we wrote the query, we fired it. So in the background, how is it working? Like what is executed first? So at first, see, like the database is going to take a from statement. So from statement is it is going to select the table that you have selected. So it is going to take which table you are taking. It is going to bring up that first, and then it is going to say where the filter that you're saying. This is done why? Because the where clause filters the data. So if you do it later, you're going to have more memory or more performance issues. So when you have licenses, when you are working on cloud, each query is costing something to the company. So let's say if I am firing a query which brings out 5 million rows from data, it would slot. There's something called slot timings in Google BigQuery. So slot timings would be there, and that is amounting to some dollars. So I would not want to have a query which is going to get used every day, which is having a large slot timing. So I would filter my data to the data that I only need. So I do not want the entire data to come up. So let's say if I want to see there's a student data, and you would have student numbers there. So numbers, I talk about the numbers that you have scored, the grades or numbers that you have scored. and I would want to see the top 5 students. So I would filter the data at first. I wouldn't want to see all the students, then order by, and then take it out. I would filter the data first to the top 5. I would just order by descending of the numbers, and I would take the top 5 first. So instead of that, it's better to take the filter first. So group by again is done next. So you sum up your data so that the data number of rows is less. Having again filters your group by functions, and then you select the data. And the last is when you order. So the entire thing is done is when you order the data. So order by is generally not preferred because it finds no use actually in a real world scenario. So in a real world scenario, when we process this data in a different system, because directly for a user base, we're not going to give them a query. So let's say at Walmart, let's say I have a business. Business is my finance team. So I wouldn't directly give them a query to run. They are not sophisticated users. We call them unsophisticated users. So for them, what we will do is we will prepare a report and we will give them a report for certain sales amount. So why do they want to see the order by here? We can do that order by in a front end systems. So order by actually adds an overhead to the systems. It makes the query a little slow. Right now, when we did that, you wouldn't be able to see that slowness because this is just 5 or 2 lines of code. It will still be taking us, just seconds. It took what a little just seconds it took, but when you fire it on a system which has petabytes of data, so actually you would see 30 days worth of slot times being consumed just for querying one data. So you wouldn't wait 30 days to see the data. The slot time is 30, but the data will come in 2 to 3 5 minutes 6 times. On a typical average, you would see one query will take about 2 to 3 minutes at least. And on a larger side, if your query is not optimized, you would say 5 minutes, 10 minutes, 20 minutes to even see just fire one query. So it's how we try to optimize our query in a better manner going forward when you talk about the corporate world. So that is what execution order is. Yeah. So now we talk about the operators. Yeah. Filtering data when used inside the operators will give you a lot of feasibility to actually work with different sections of data. So when we talk about now we were talking about the where clause, right? So यहाँ पे क्या हो रहा है कि अभी let's say ये वाला जो example है, the first example is student का data. So यहाँ पे हम क्या कर रहे हैं, स्टूडेंट्स का डेटा को हम एज के बीच में निकाल रहे हैं. तो फ्रॉम स्टूडेंट्स एज्ड बिटवीन 18 and 12, तो 18 से 22 के बीच का स्टूडेंट्स वी आर टेकिंग इट आउट. एंड सेम आई थिंक नेक्स्ट में व्हाट वी आर डूइंग, वी आर टेकिंग फर्स्ट नेम का जॉन होना चाहिए, लास्ट नेम डो होना चाहिए. यू कुड आल्सो यूज जस्ट वन कि लास्ट नेम सारे डो वाले को निकालना है या सारे जॉन वाले को निकालना है. और यू कुड से फर्स्ट नेम जॉन होना चाहिए और उसका एज 18 होना चाहिए. You could say a lot of you could do a lot of mix and match between these operators. So not and is nothing but it gives you two conditions together. So दो conditions को साथ में लगा सकते हैं कि एज 18 है, नाम जॉन है. और कर सकते हो एज 18 है या फिर नाम जॉन है, तो दोनों आएंगे. और भी आएगा और ये वाला भी आएगा, ये वाला भी आएगा. एंड में इट्स दोनों होंगे तब आएगा. सो दैट इज द डिफरेंस. एटलीस्ट वन कंडीशन मस्ट बी ट्रू, वहां पे कंबाइंस मल्टीपल कंडीशन. सो व्हेन आई एम सेइंग कि फर्स्ट नेम जॉन होना चाहिए और एज उसका 20 होना चाहिए. सो जब दोनों ही ट्रू होंगे तभी कोई भी बाहर नहीं, मतलब रो उसके रिजल्टेंट सेट में आएंगे, नहीं तो नहीं आएगा. और में क्या होगा अगर मैं बोलूं कि जॉन फर्स्ट नाम होना चाहिए या और उसका एज 18 होना चाहिए, तो या तो 18 वाले भी आ जाएंगे, जॉन वाले भी आ जाएंगे, दोनों आ जाएंगे. So not inverts a condition. So I would say first name not John. So not John वाले सारे आ जाएंगे. Between does specifies a range. So this is pretty simple. We go to joins. Now this is typically one of the things that we mostly also ask in interviews. So interviews, when I take interviews in my company, I ask join questions because this tells you how much of a clear concept you have about SQL. So I'll explain this with a diagram. We go ahead. I think my screen froze. Are you still able to see and hear me? Because I think my browser froze. It
No,
mirrored the data.
it's visible. A plain white screen is visible.
It's visible, right? Okay. All right, but I don't see. Okay, I see my browser now. All right. So we were talking about. Let me delete this. Okay. So we were talking about joins, right? So let's consider there are two tables here. I think we also have a whiteboard on Google, right?
Yes.
Let me use that. This whiteboard isn't good.
In the activity section, we have a whiteboard.
Mhm. So this Jamboard, are you able to see this?
It's loading. We need a access from your end. Or we can use that tutorial point whiteboard if required.
Okay, let me just use that only. Yeah, let me know when you can see.
Yes, it's visible.
Okay. So one way while we were talking about was a star schema, right? So on the front end systems or the reporting systems, just Tableau, Power BI, or anything other than that, when you have a schema, you can directly take two columns from two different tables and show them in a one place. But let's say you want to see something in a query. And same, let me continue with the same example. We had orders, and let's say we had customers, right? Custom orders. Now, when I want to, let's say, show my sales or sales by customer. So each customers, let's say Ritesh had $500 worth of purchase. Uh, Someone named Divya had $600 worth of purchase. I want to see something like that in a query. How can I do it? Because my customer lies here and my orders lies here. So some way I need to join them together to show it. So there are 3 or 4 ways to join, so which we will be talking about. So now let's say we had customer. For all the joins to work, there should be something common between these two. So one column should be common for these to join. So we were seeing that this had customer ID, this also had customer IDs. So we need to join something on something, right? So you need to have one common thing to join these two tables. So now when we see, let's say we had customer in common. So there are 3 types of join. So one is inner join. So what it does, it will take the matching columns between the two places. So let's make it simple. So one table you have where you have 1, 2, and 3, and second table you have 2, 3, and 4. So inner join will do what? It is going to take the matching ones. So 2, 3 from here and 2, 3 from here will give you 2 and 3. Right. And second one is left join. So left join is, let's say this is your table which is left. So left join will do what? It will give you the matching ones, everything in the left and the matching ones. So it is going to give you 1, 2, 3 here. Same for right join. When we take, it is going to take you matching and everything on the right. So 2, 3, 4. Full outer will give you all of those. So third is full outer join. It is going to give you all of 1, 2, 3, and 4. It will give you. So the best way to understand this graphically is using a Venn diagram. So I'll tell you how. So let's say this is table 1, and this is table 2. So T1 is this and T2 is this. So inner join is going to give you this area. So the columns which are matching in those. So let's say this customer table might have thousands of customers, but might be those out of those thousands of customers, only 5 or 10 might have ordered. So it is going to only show 5 or 10. So that's what. So the rows which are matching in both, it is matching in both. This is an inner join. This is the inner join. Second one was left. Left would do what? Same Venn diagram. It is going to give you this area and this area. So everything in left and the ones in left. So everything in left, sorry, and the matching ones. So that is going to give you left. Right is going to give you, so the matching ones and this area is what right is going to give you. And the full outer join, the last one that we have, is going to give you the entire thing. Okay. Any questions here? Like, I think this is one of the very important topics that everybody should know about, how a join works, because when you start writing a query, when you start filing queries and actually working in a corporate sector, you wouldn't have time to go and brush up your basic skills. So this is very basic, and later when you start writing 100 lines of queries, the big queries where you are joining 3 or 4 tables, and you are actually using all of the things and clauses that you have studied today, it will be very difficult to go back and brush up base points. So here, do you have any questions? Because I'll start with what kind of questions I ask on joins. I have a table prepared, and I'll ask you guys the same questions that I asked on during my interviews. So that is coming. So before that happens, do you have any questions on the concept? That is very clear. Right? With the diagram, you understand which side will take what. And one more thing about this is we also have null fields in a column or a row. So null fields is nothing but a null row or null values. So null is not equal to null in any case in database. So null will not join any other about null, right? So that is something it is not going to join. So let's go ahead and see the actual question when you talk about joins. So let me move this. So these are the two tables that we have. So one is 1 0 null. The second one has 1 1 0 0 null null. So here you see there are, just 1 second. So these are two tables. I heard somebody was asking what's the difference between a full inner join and a full outer join. So there is nothing called full inner join. It's an inner join and your full outer join. So inner join is going to only give you the matching ones. Full outer join is going to give you the full ones, and you're going to experience that here right now. Like when we actually work on this, so you're going to experience that. So let's say, let me just show these tables together to you. Okay. So table A was 1 0 and null. So this is actually a question that I asked in the interviews. Right. So now I want everybody to tell me what is going to be the output when you do a inner join, when you do a left join, a right join, and then we will see as well like what exactly we will get, and a full outer join. So before you start writing your answers, just one thing, that null is not going to match null. So in DBs, null is not equal to null. That is one concept. This is an equal to sign. This is a not equal to sign. Go ahead. This mirroring won't stop.
No.
Again, just one when talking about nulls, I said that null is not going to be equal to null. But when you talk about left join, right join, if you remember the Venn diagram that I was talking about, left join will have everything in the left and the matching ones. So right join is going to have everything on your right and the matching ones. Okay, so it would be something like it will match this, it will match this, this will match this, this will match this. Since null is not going to match anything, it is not going to match anything. So let's also run this. So we have DBO1 and DBO2, so test 1 and test 2. So let's say we are selecting right now, just select star, we will move there from DBO test 1. Let's name it as so we can name these while we are writing this. We could just name our tables something so that later it is easy. So I'll tell you how it makes sense. We are naming this as B. And now this is one part of the syntax. You're just saying which tables to join and what join you're preferring to. And then second part of the syntax is where you're going to tell what exactly it is going to join on to. So A dot, since we have column 1 in both, so A dot column 1 is equal to B dot column 1. And now let's just take A ka column 1. Right. So let's see how it is going to run. So as I said, so 1 and 1 is going to join 2 times, 0 and 0 is going to join 2 times. So it actually becomes difficult when you have redundant data. To actually visualize what exactly is going to happen is difficult when you have redundant data in your systems, and it is going to have redundant data in your systems. So when you actually work and start, taking, systems from corporate or like from product based companies and even the normal ones, you will see the data has a lot of duplicate values, and it will have. In a real world scenario, I'm a person who is ordering at, let's say, Flipkart. I would order 10 times in a day. I can order 5 products in a month, right? So I would have 5 times in my transaction systems or in my normal systems as well. I would have 5 times of data. So that is, you are going to have that.
Ritesh, could you please zoom in?
This one.
Uh, is it possible we can zoom in the font size or increase the font size?
I think from your systems, if you just zoom in the screen, that is would be better, right? You could
Yes.
zoom in the screens.
For all the attendees, you can just click on the screen and you can have an option of zoom in and zoom out.
Yeah. So at a particular area, just zoom in the screens. So now the syntax would be same in all the joins. It will still be same. This is going to change. The inner join, I'm just going to write a left. I'm going to write right or left full outer join. The else it is going to be same. So the first part of the syntax tells you from which table to which table you're going to join. Second part of the syntax tells you condition kya hoga. Okay. So the next part, when we talk about the left, so it is the same as that, but it is just going to add everything in the left as well. So let me go ahead and show you what happened here. So when in left, what happened? The same matching, what we read, but it is going to take everything in the matching and the left. So what was matching? Matching was inner join. So in inner join, we had this, right? And it is going to take everything else that was in left. So it is just going to add the null value here. On the same concept, when we talk about right, it is going to take everything, the inner join, and add the two values again. See, it took everything as an inner join, just added the two values in null. So what are the two values in null that we were talking about? The ones that you have there. The ones that you had here, it is just adding that to the right join. And full outer will give you all of it. So it just adds both. So the inner and both the areas. So that's why I was explaining the Venn diagram very clearly. So full outer join is doing what? It is going to add everything. So the inner join, this is inner join and the full area. So the remaining part of both the areas. So it is doing the inner join. Inner join is nothing but this value, and it added the full area of other sides as well. So this null and picked these two nulls as well. So the question that I ask here is not the numbers that you are like, tell me the full output. I ask what will be the number of rows that you will get when you do the following join. So I include in the redundant values, I include in the null values, so that the concept that the person has on SQL, on joins, I understand that he has a good concept. So this is a very basic question, but it gives understanding to me as an interviewer that this person has a clear understanding of joins. So he won't be having issues while he's writing the queries. No, you don't have to remove the redundant data. Redundant data is actually a part of your data. So redundant data will be there in your systems. You will see redundant data you need to remove it when necessary, but as a part of DB, you will always have redundant data. So this question that you wouldn't remove the redundant data, this was just to check what exactly you want. So let's say now if there is a redundant data which is not needed. So in a dimension table, you have customers twice. So you have my name 2 times. There you need to remove the redundant data. So where it makes sense. But in an order table where I have 5 orders and I have 5 times my name, you don't remove the redundant data because that is necessary there. Okay, I think I am way beyond the time as well. Okay, so I think joins post that you have the same that we were talking about, the data types. Integer data type is your integer from a certain that you can find in the book as well. This is more of a hands-on. So integer, you will have certain negative points to certain positive points. The entire cycle is there. The varchar will have a variable length string. You can define the size in front of that. So for names, we usually give 50, or for like full names, when you have, we give 100. You could define based on that. Date is going to be a date value. Float is a floating point number. Boolean is a true false value. I think this, from if you are from a coding background or if you are from computer science, you would have already known. In any language, you would have specifically, I would say, quite similar data types. So that is same. Now let's talk about subqueries. This is something which actually this is not being used mostly, I would say. In industries, we don't use this because this actually takes a lot of time. But it is useful to know because you might find sometimes that people ask you these questions. So subquery is nothing but when you are using a different query inside a different query. So query 1 and query 2 you are using. So now let's talk about the same thing where you were doing here. So let's say we had again the order table. And we had this customer table here. Now I would want, let's say, for you to write, select all the, get me all the customers who ordered more than 5 times in this month, right? So now there are 2 ways to do this. One is you can join this. You can join these both, which is a better one because joining is more cost efficient. Cost efficient, when I talk about, is a term that we use in efficiency or optimization, is like most cost efficient or more efficient query, rather than a subquery. So in subquery, how you would do is you would, let's say, select select your customers from the customer tables, select customers from your customer tables, where in the where, and inside where customer ID, since these are common in these two, customer ID is in. So in is again a operator that we used. In means like it is present inside, and again the next query. So next query is you're going to count your group by and count. So I'm going to use select your customer ID from this table and group by customer ID, and where count is greater than 5. So now this query, the inside query that I have, is going to return you only those customer IDs who have ordered more than 5 times. So those are written. Let's say 5 customer IDs are being returned from them. So now these 5 customer IDs are going to pass in the outermost query, and that is going to give you all the details of that customer for these 5 customers. So this is what a typical subquery would look like. So in this, you would have multiple types. One is single and multiple. So same, like if you do a select star, it will be single, and inside this again you have a set of nested subqueries. Then that will be a multiple subquery. But again, this in your typical day-to-day life in IT, we completely avoid that. We do not, until unless it is very necessary, and the joins is something that we wouldn't want to go through. In very, I think, small cases is when we use this. And the third one is the correlated subquery, which is like completely avoidable. So correlated subquery is when you refer to the same query on top. So simply when you are referring to the upper query in the lower query. So when you are referring to the upper query in the lower query, it is called a correlated subquery. So it's referring to the same table and referring to the other queries as well. So that is mostly used in update and your delete statement. So when you want to update your tables, so you would use, let's say, update the tables, update your columns or rows where this is there. So in the lower subquery, you would give your filter where exactly you want to update, and the upper subquery you would update that. So you're using the same tables in both the levels of subquery. That is a correlated subquery. Again, that is again very performance consuming. So in a when you write, let's say when you go on HackerRank or these kind of websites where you practice your SQL, you will see these kind of questions. But when actually you go on an industry level, you will see that very less queries or views. When you see very less queries are actually using this. So we generally do not use, we avoid using this. When I want to, let's say, just there are two types of queries that I fire in a day-to-day systems. One is when I just want to analyze the data, like something that I'm working on an application where I am seeing some customer data or a sales data, and I want to just see in the backend systems as well. So what I would do is I would just fire a select query and I'll just see the data. There I can fire anything because that query is not being stored. It is just for my use, and I'm firing it for just my use, and I'm just firing it, seeing the data, and that query is done and dusted there. So there, it is not necessary that my query is optimized. But in a real world, when I'm actually using it in a view and I'm using it to give that query as a input to another system, there I would optimize my query and I would not use these things. Okay. Now this is something again I ask in my interview. So there are two things. Whenever I take a round, I would take the first 30 minutes for SQL, and those 30 minutes I would ask my joins and window functions. So these are two very important things that you talk here. So let's say what exactly is these. So row number is going to give you 1, 2, 3 for each row. It's like a primary key. It is going to count the row number and giving you 1, 2, 3, 4 every time. Rank is something that you have based on, let's say, when I talk about rank is ranking something on top of something. So let's say when you talk about, we were just seeing the data where salesperson sales were there. So for each sales, let's say Pawan made 5 sales in a month. In 5 months, he made 5 sales, right? So first month he made some 5,000, second month he made 6,000, third month he made 7,000. So now when I want to rank his sales as per his sales in a descending order, so he would give 1, 2, 3 numbers to that particular place. That is ranking. And dense rank is also similar to rank. It's just a bit different, where I'll explain. So let's say rank and dense rank difference. So let's say this is me, and I had sales 5,000 here, 500 here, again Ritesh, again 500 in the next month, again Ritesh, I had 600, and now I'm using rank. So since these two are same, right, so it is giving you 1, 1, and then rank is going to skip this 2 and it will give you 3 here. So this is rank. So when you're using rank, this is what you will get. But when you have redundant values and you want to not skip values, you use dense rank. In a typical scenario, when you don't have redundant values, you wouldn't see a difference. Now dense rank is going to give you 1, 1 and will give you 2 here. So that is the difference, basically. So let's say if we can quickly write, because this is I think mostly the last topic, so we can quickly write a scenario as well. Sales data. And somebody was also talking about normalization. Normalization is a very big topic. It's probably possible we can do some other time, because it is going to take its own an hour to do that normalization. Okay, so we can take it some other time. Normalization is nothing but structuring your data. There are 4 types, 1NF, 2NF, 3NF, and the boys BCNF. But that is something as a big scenario. And in analytics world, we mostly use denormalized data, unstructured data. So structured data can be structured in certain order. So that is what normalization is. My syntax is right. Yes. Using okay.
Vidya, you can just zoom in and zoom out,
Yep, yep.
so you will get a clear screen.
So I'll just also spell it out. So it's select employee name, sales amount, rank over partition by employee name, order by sales amount, descending as rank from DPO sales data. So I'll also explain you what this I can just replace by a star as well. So with star, I can add a few things. So if I just replace that by star, this should also work. So since is active is also going is coming, I don't want active, so I would just do this. I'll just select statement. Also, there's one optimization technique. So mostly we do not use select star. We keep the names. So it takes less performance time. So instead, let's say if you have 10 or 15 columns, and if you want just 3 columns, do not use star. Just take those columns names. Even if you have 4 columns, instead of using star, just take the 4 column names. It is going to be a better performance. So when we see this now, we will see that for Pawan, you have 1 and 2. So since we are using descending, the higher sales data has a lesser rank, and the this sales data has a second rank. So now this is, and partition is you're just, it's kind of a grouping by and then giving number. So partition has a partition and bucketing is a, I would say, quite advanced concept. So where you partition your data into different areas, so that you could mostly the partition is done based on your date column and your names also. Let's say you want to refresh a certain point of your table, so that's where the partition is done. So it's like splitting your tables into a certain part. So here the splitting is done based on the names, so that each person has a ranking order. So if I do not use partition, it will be 1, 2, 3 based on the sales amount, but we want to partition rank the each person based on the sales amount. So kind of it's in this case it's kind of similar to group by. We are just grouping them together and then we are just giving a rank over that. So now the question that I ask is, I want second salary data. So let's say for each person I want the second highest sales amount that he has done. So in this case, let's say I want Avatar to be a part of my resultant set. Here I want Kishan, and here I want Nimit, and here I want Pawan. So now this is a typical scenario where most of the people are not aware. So what would happen? You cannot use a window function as in the where or a having clause directly. So you will have to use it under some other query. So you cannot, if I just give here where might rank equal to 2. Let's say I just want to take this 2 out. So I cannot do it. So this is going to give me an error. So I cannot do it. This is incorrect syntax. Sorry, where I cannot do it. But if I want to get the rank out for second person, there is something that somebody could use, that which is called CTE function. So this you could also use and try. So CTE is nothing but as a named result. So it's called common table expression. So the syntax is with CTE as, and so it's different. You might have heard a temp table, but it's different than a temp table. It's mostly now this is creating a table named resultant. So the result of this is being stored in this table, which is not a table. It's just a named result, named resultant set. Now when I want to see, if I want to select star from CTE, where since I had given my alias rank before, so my second rank is coming out. Generally, I should not be giving the rank name because it's a function. So let's say we give it RK. So it's one of the naming convention that we use. We do not use function name as name names, but still it is working. Yeah, see. So now you're getting second rank of each. So this is one question that I typically ask with not this data, but I say for each department, there are certain people working and I want the second highest salary from each department. So how would you write that? So this is something how you would do, because there's no other option. The other options are very complex. So I would ask the optimized version of that. You could use a subquery and then get the numbers. You could use a subquery to get those numbers. You could use joins to get those numbers, but the best and the most optimized answer would be this. So in an interview, it's not just about giving the right answer. It's about also, I would say in the full stack world as well, or as well as the analytics and SQL world, you would give the best possible optimized answer rather than just giving an answer. So that's something about rank. So you would have same concept as for row number, as well as your I would say dense rank. Also, there are other window functions as well that you can explore. Something which are more complex ones, something as entile. These are used mostly for finding your quartile statements in a data science world. That is something which you can also explore. Entile is something that is also a window function that you can use. Okay, so today what we did was to understand RDMS concept. We created databases and tables. We inserted data into our tables that we created. We used SQL clauses, and we also found the execution order. We used one SQL statement which had all the SQL clauses that we explored. We tried to filter our data. We performed various types of join. We understood how in the interviews you would use actually a join question, so that you would want to prepare when you want to practice your joins. Do not just practice joins with a direct data. Use it with a redundant as well as your null data as well, so you would learn better. Recognizing and using the different data types, applying aggregation functions within and group by. We also tried understanding subqueries, leveraging window functions. Other than that, we also went through CTE, which is common table expressions, which is used. I think CTE is being used everywhere, and wherever, like I would say I use 5 to 10 times CTE every day while I work, because every time you work, you would have to have a smaller statement. So let's say let's say this statement is not just one line. This is a 100-line query, and now I want to again write something as join. I want to join it with some other statement. So I do not want to just copy the 100-line query 5 times, right? I wouldn't copy that 5 times, 6 times, and then use it. My query then will be 2,000, 5,000 lines. So I would just store it as a CTE variable, and then I would like CTE named result, and then I would start writing my query based on CTE. So I would use CTE there. I would again use CTE there, and on top of that, I can again use another CTE. So that query will be complex, but not look as complex, and it will be better for another developer to understand what exactly I've been doing. So that's about it. Yes, normalization is the interview that you might have given would be for core DBA roles and core, I would say, SQL manager roles. Data engineer roles will have normalization question. When you start working as a data engineer, you should know your entire process and your DB roles. So roles which are more inclined to the DB would have SQL questions. Let's say if you're working on a full stack world, your more inclination in questions will be in data structure. So that's something that you will see. All right.
Hi Ritesh.
Interesting.
Hi everyone. बोर तो नहीं हो गए? कोई बोल ही नहीं रहा है कुछ. Everyone, your mics are on. If you have any query, you can ask Ritesh. Is waiting. I believe Ritesh there would be no queries.
That's good.
Thank you so much, Ritesh, for the wonderful content and wonderful session. I believe that your expertise and your insights would be valuable to our participants.
Okay. Somebody is asking what topics should one prepare for DA interviews. So data analyst, I suppose, would want to prepare SQL. SQL should be super strong. Then you would want to have one ETL tool. So ETL tool is nothing but extract, transform, and load. So one ETL tool, any, you could go for SSIS, you could go for Alteryx, you could go for ADF is a cloud tool, Azure Data Factory, and one visualization tool. You could pick Power BI, you could pick Tableau, Looker, anything. So just touch base on all three areas: SQL, one ETL, and one visualization. That is a DA's role.
Chavi, you got your answer.
Sir, one question, sir.
Mm-hmm.
Sir, if any student is using Microsoft Workbench, and is it like the same the tool what you are using, and do we have any disadvantage over it, kind of stuff?
See, in different industries you will have different licenses that they will have. Some won't have my Microsoft license, some would use Google. And in a big firm, like for my firm, we have AWS, we have Google, we have all the databases. So different team uses different softwares. So the basic concept should be clear. So if I'm talking about Python, my Python, if I'm using in any IDE, that's not an issue. Any industry that you work on might be using a different IDE. They would have a license for that. So let's say if I'm using SQL, so I don't care if the industry in front is using a Google BigQuery, or they are using like entire BigQuery language, or they're using SQL Server, or they're using anything that is mostly an IDE. So basics should be clear, and that you would slowly adjust on whatever tools that you're using or whatever the front end they're using.
And sir, top of like the webinar you have gone through, like, sir, I have also gone through like basics in my college. So based on today's webinar and what I have learned on my college, can you suggest, sir, kind of project which I can work on, kind of basic project, so that I can do practical stuff as well through some kind of data and all?
So if you are looking for a DA role, so my role is not just DA. My role is more of a SDE3 role. So DA role would be your. You could start with, either said, ADF. Azure Data Factory won't be free. I think I'm not sure if it is free, or you can have a license with just your credit card. You could, it won't charge you, but you will have a free license for that for some days. So you would start with an ETL tool, try to transform your data into certain, and then load the data into a database. And from that database, you would want to start cleansing your data and seeing the structuring the data, and then load it into any visualization tool. So that could be a complete project for you. And if you are looking for a DE role, which is a data engineer, so there mostly you would want to learn PySpark, and you would want to learn for ADF and PySpark together.
Sir, both one is come under data analytics itself, or like it's different data analytics part?
Right. It's a different. So analytics engineer would know all of those, but the roles are different. A data engineer is the one who manages the entire data, loads the SQL servers for us. So I am into analytics engineering. So for us, there's a different team who does all of those work. They load the data, they cleanse the data, they give it to us. And from that point on, we analyze the data and we do analytical part. We give users, we tell users what actually the data means. We'll recommend them what exactly to do so that the data is good. So data analytics is something which companies will only have when they are into profits. So data analytics, once you have profits, we can help more to get more profits. Suggestions we could give, like let's say if you are using, if you have a store which has 4 floors, and each floor is like, first floor is your jewel shop, second floor is your child accessories, third floor is your women's shop, and fourth floor is men's. So you have been working on that store for past 1 or 2 years, and you want to see how you want to maximize your profits. So if you come to a data guy, he would see the data that for each stores, for each floor, what exactly the sales is, and then match it with the rent and match it with the trends, that what exactly is being, like, how people are actually buying from each stores, and which sections of each stores are being bought more. Based on that, I can recommend that, let's say, a lot of not a lot of men's clothing are being sold for the past 1 year. So I would do, and a lot of women's clothing are being sold. So I would say, let's move men's clothing into the half part of the jewel section and expand the women's clothing into a bigger section. So this is what analytical engineers would do. They would analyze the data, give scenarios. So we do prescriptive, descriptive analytics, and then data science will tell you, like, with this, uh, with this approach, how much profits are going to make for the next year. So that is forecasting and data analytics. So all are different. These are all part of one sub statement, but these are all different. One person cannot be a data engineer as well as data analytics as well as data science. There are multiple teams in an industry.
So, sir, in short, the first one is data engineer. Then we have database administration.
Data engineer, they would have it in a domain, and then you will be molded into a particular role based on what I.
Sure, sure. Thank you so much, sir. One last thing, sir. Just can you share your LinkedIn profile and connector?
I think,
I
yeah,
will
sure.
share all the details in the group. Please do join the group. I'll share the PDF and Ritesh profile. Okay, so no worries, and you will get the recording in our social media platform. So all the attendees, please do join our WhatsApp group. So you will get the recording and the PDF and the LinkedIn profile of Ritesh.
Okay. Thank you, guys.
Thank you so much, Ritesh, and thank you everyone for joining. Thank you so much, Ritesh, once again, and we're
Yeah,
looking forward to
thanks.
our more future sessions. And it was a wonderful content and session. All the students, I'll be there. Please do join our WhatsApp group and